All right, everyone, get ready for another deep dive. Today, we're tackling the world of supercomputers.
A world full of mind-blowing tech.
Yeah, and focusing on one in particular, it's called Frontier.
Oh, Frontier. That's a pretty big deal over at Oak Ridge National Laboratory.
Definitely a big deal, breaking records and making headlines.
This week especially.
For sure. And that's actually our source for today's deep dive. An article with a pretty long title, but it sums things up nicely.
You mean Frontier supercomputer surges to 1.35 exaflops to tackle the biggest science problems on the planet.
That's the one! Published just a few days ago on November 29th, 2024.
Always exciting to see new developments in supercomputing. And Frontier is a perfect example of how fast things are moving.
It first came out in 2022, right?
Yeah, back then it was already smashing records. It was actually the first to hit the exascale barrier.
Okay, hold on. Exascale. I feel like we need to break that down.
Exascale, yeah. That means it can perform at least one exaflop, which is, well, a mind-boggling number of calculations per second.
The article mentioned Frontier reached 1.35 exaflops, but honestly, that number just sounds, I don't know, massive.
It is massive. Seriously massive. 1.35 exaflops means Frontier can crank out 1.35 quintillion calculations every second.
Okay, a quintillion. So that's
One with 18 zeros after it. It's hard to even fathom that kind of scale.
I mean, I've seen some big numbers, but I don't even have a comparison.
Think of it this way. If every single person on Earth did one calculation per second, it would still take us years to match what Frontier can do in just 1 second.
Whoa. Okay, that puts it into perspective. That's insane. So how did they make this already super fast machine even faster?
Well, it's not just about adding more, it's about adding smarter. They added 400 new nodes, so the total is now over 9,800.
Nodes?
Yeah, think of each node like a mini supercomputer itself. Each one is packed with CPUs and GPUs all working together.
I see. So more nodes, more power.
Exactly. And that translates to a crazy speed increase.
Yeah.
150 petaflops faster, to be exact.
Petaflops, now that's another one.
We could do another deep dive on all the flops another time, but to put that into perspective, 150 petaflops is about the same computing power as Frontier's predecessor, Summit.
So it's like they took Summit and just stacked it on top of what Frontier could already do?
Basically, yeah.
Wild. But the article also mentioned mixed precision computing. What's that about?
That's one of the really clever things here. Not every calculation needs to be done with the highest possible precision.
Right, I guess it depends on what you're trying to do.
Exactly. Mixed precision lets Frontier use lower precision when it's okay, for certain tasks that don't require absolute accuracy.
So it's kind of like using a calculator for a quick estimate versus pulling out, like, a super precise scientific instrument for a really complex measurement.
Perfect analogy.
Right.
All about working smarter, not just harder. And that's a big deal for things like AI and machine learning.
AI, yeah.
Huge. By using mixed precision, Frontier set a new record for the HPL MXP score, a benchmark specifically for mixed precision computing.
What was the score?
11.4 exaflops.
11.4. So that's way faster than its normal HPL score, right?
Oh, then 8 times faster. That's the power of working smarter. This opens up a whole new level of possibilities for AI, especially for really complex problems.
So, okay, we've got this insanely fast machine. It's super efficient. But what does all this actually mean for, solving problems in the real world?
Well, imagine being able to simulate a year of human brain activity in just a few hours.
Wait, seriously?
With 1.35 exaflops. That's within reach. That means we can understand consciousness better, develop new treatments for brain diseases, even create AI that's closer to human thinking.
Whoa, that's mind-blowing. So it's not just about medicine, right?
No, not at all. We're talking about understanding how supernovas work, which could unlock secrets of the universe. Or looking at atoms in a way that lets us design revolutionary new materials.
Like what kind of materials?
Imagine stuff that's lighter than air but stronger than steel, or solar panels that capture energy almost perfectly. The possibilities are really endless.
This is getting pretty philosophical. But it's all made possible by the people behind the scenes, right? The folks at Oak Ridge.
Oh, absolutely. Behind those crazy numbers is a whole team of brilliant people.
What are they doing exactly?
They're the unsung heroes, constantly working on the software, the algorithms, keeping Frontier running at its peak. It's a huge team effort.
It's a good reminder that even with tech this advanced, it still takes human ingenuity to make it work, to make those breakthroughs.
Couldn't agree more. And it's not just the Oak Ridge team either. The article mentions software developers, people working on math libraries, and the collaboration between HPE and AMD.
So it's like a whole ecosystem of expertise coming together.
Exactly. It's like a high-tech orchestra, everyone playing their part to make the music. And speaking of the future, the article mentioned Summit, Frontier's predecessor, is being retired.
Oh, wow.
So does that mean Frontier is the peak of supercomputing, or is there more to come?
Good question.
That's the thing, right? We're just getting started. Frontier gives us a peek into the future, but technology keeps moving forward.
I guess the next question is, what kind of future will it be? What kind of discoveries will Frontier make possible?
Well, let's dive into that.
Let's do it.
It's really amazing when you think about the scale of this thing.
Yeah, we've talked about how powerful Frontier is, its potential, but we haven't really touched on the infrastructure itself. It's huge, right?
Oh, yeah. We're talking about a system with over 9,800 nodes, all connected together. It's mind-bogglingly complex.
9,800 nodes. I mean, I can barely keep track of the files on my computer. How do they even manage all that?
Well, think about it like this. To connect all those nodes, they used over 90 miles of cable. It's practically a city of its own. A digital metropolis with data flowing through it like traffic on a highway.
A digital city. That's a pretty cool way to visualize it. And I guess just like a city needs a power grid, Frontier must need a ton of energy to run.
You're absolutely right. The article didn't get into specifics, but the energy consumption of these supercomputers is something to think about. All those calculations generate a lot of heat, too, which has to be managed.
Right. I haven't thought about the heat. So does that mean supercomputing isn't very sustainable?
That's a really important question, and it's something researchers are working on. There's a big push for energy efficiency in supercomputing.
That's good to hear. I mean, we want to push the boundaries of computing, but not at the expense of the environment.
Exactly. It's about finding that balance. And it's going to become even more crucial as supercomputers keep evolving and get even more powerful.
So what does that evolution look like? What's next after Frontier? Are there things on the horizon that you're particularly excited about?
Oh, there's some really cool things happening. One that could totally change the game is quantum computing.
Quantum computing. I've heard that term thrown around, but what is it exactly?
Well, it's still early days, but quantum computers are fundamentally different from the computers we use today. They use the principles of quantum mechanics to do calculations, which opens up a whole new world of possibilities.
Okay, so it's not just about being faster, it's a whole different way of computing.
Right. And that means they can tackle problems that are impossible for even the most powerful supercomputers, like Frontier.
Like what kind of problems?
Well, one example is breaking the encryption we use to keep our online data secure. A quantum computer could potentially crack those codes in a fraction of the time it would take a classical computer.
Wow, that's kind of scary, but also pretty amazing.
Right, and they could revolutionize other fields too, like material science and drug discovery. We could design new materials and drugs with incredible precision.
So does that mean quantum computers are going to replace supercomputers like Frontier altogether?
I don't think so. It's more likely they'll work together. Each type of computer has its strengths, so it's about using the right tool for the job.
So a hybrid approach. That makes sense. But in the end, it's not just about the machines, right? It's about the people using them.
Absolutely. Supercomputers are incredible tools, but they're just tools. It's the scientists, the researchers, the engineers who are driving progress. They're the ones asking the big questions and figuring out how to use these tools to get answers.
So what are some of those people working on? What kind of research is actually being done on Frontier?
Oh, it's an incredibly diverse range. You have physicists, chemists, biologists, climate scientists, all sorts of disciplines using Frontier to explore their fields.
What are they actually doing with it?
Well, some are trying to understand the origins of the universe. Others are designing better solar panels. Some are even simulating the human brain to try to figure out how it works.
That's incredible. The range of research is so vast, it really shows how supercomputing can be applied to just about anything.
Exactly. It's not just about numbers and tech specs. It's about using these tools to make a positive impact on the world.
Well said. This has been an amazing exploration into supercomputing. We've covered so much, from the power of Frontier to the challenges and possibilities for the future.
It really makes you think about what we can accomplish when we combine human ingenuity with these incredible machines.
Before we move on to part 3, I want to leave our listeners with something to consider. If you had the chance to work on a project using Frontier, what would you study? What questions would you try to answer?
It's a great question. Dream big, think outside the box. We'll be back soon to dive into some specific examples of the groundbreaking work being done on Frontier.
Welcome back for the final part of our deep dive into the world of supercomputers.
The grand finale.
Exactly. We've explored the power of Frontier, the tech behind it, but now it's time for the big question.
The so what?
Yeah, how is Frontier actually being used to solve problems? Real-world stuff.
Well, the article we've been talking about highlights some really interesting examples, things that show the impact Frontier is already having.
Okay, like what? Give me an example.
Well, one that caught my eye was modeling cancer cells.
Oh, wow. That's got to be incredibly complex.
It is. We're talking about simulating something so tiny, but the implications for human health are huge. It's not just about replicating a cell, it's about understanding its behavior, how it interacts, how it responds to different treatments.
So it's like a super-powered microscope, but instead of just seeing the structure, you can actually see how it changes over time.
Exactly. And that's a game changer for developing new treatments. Because researchers can run virtual experiments on Frontier, testing different drug combinations, seeing how genes might affect the success of a treatment.
So it's like personalized medicine, but on a whole new level. Amazing. But the article also mentioned something completely different. Supernovas. How can a supercomputer be used to study something that's so massive and so far away?
It is mind-boggling. Supernovas are some of the most powerful events in the universe. And to understand them, we need to unlock the secrets of how stars and galaxies form.
Right. We can't exactly fly out there and take measurements.
No. And that's where Frontier comes in. They build these super sophisticated mathematical models that factor in all these forces, like gravity and nuclear fusion. It's crazy complicated stuff.
And with those models, they can actually recreate a supernova on Frontier.
Yeah, and watch how it unfolds.
Yeah.
Study the results. It's like having a time machine and a telescope all in one.
That's incredible. What about something a bit more, down to earth? The article also talked about research into the atomic structure of elements. How does Frontier help with that?
That's all about material science. Everything around us is made of atoms. And by understanding how those atoms are arranged, we can design new materials with specific properties.
So it's like a virtual chemistry set, where researchers can just play around with different atomic combinations and see what they get.
Pretty much. Imagine being able to design materials that are stronger than steel but lighter than air, or that conduct electricity perfectly. That's the kind of potential we're talking about.
Wow, this deep dive has been a wild ride. From personalized cancer treatments to recreating supernovas, it's clear that supercomputing is changing the world in so many ways.
It really is. And I think it's important to remember that all this technology, it's not just for the sake of technology. It's about empowering people to solve problems, to make the world a better place.
Couldn't have said it better myself. And I think that's a perfect note to wrap things up on. This deep dive has just scratched the surface, but hopefully it's given you a glimpse into the amazing world of supercomputing.
Keep asking questions. Stay curious. The future is full of possibilities.
And who knows, maybe one day you'll be the one using a machine like Frontier to make groundbreaking discoveries. Thanks for joining us on this deep dive. Until next time.